Welcome to Flink Forward Asia 2024.
Apache Flink, of course, this is an overview project and I'll say a basic concept. Next, for another 30 minutes, we're gonna hear about embrace unified stream and batch processing with Flink SQL, presenting by Mr. Lincoln Lee as staff software engineer, Alibaba Cloud, Apache Flink PMC member and committer. Please join me in welcoming Mr. Lincoln Lee. Mana tepuk tangannya dan semangatnya? Alright, thank you. Good luck, sir.
Good afternoon, everyone. Thank you for listening this topic. Yeah, recently, Xintong gave you the Flink Engine 101, and my topic will be something like Flink SQL 101. Okay, yeah, I come from Alibaba Cloud, and since 2016, I have been working on Flink SQL and stream batch unification. And for today's topic, I will share mainly for three parts. Firstly, a brief introduction to Flink SQL, and then I will share you two important concepts in Flink SQL. And lastly, I will show you some concrete Flink SQL use cases and concrete functionalities. Yeah. Right now, you see another picture to show you Flink is a distributed processing engine. Yeah. The highlighted words will be the stateful computation and the unified data streams. Yeah, both unbounded and bounded data can be processed in a unified way while Flink SQL and also the Flink runtime. Flink SQL engine built on top of the unified Flink runtime. It has a unified API, use the same syntax SQL to provide a batch and streaming style processing for both bounded and unbounded data. And for the expressiveness, it consists of various SQL operations and also lots of building functions, and also give users the extensibility to connect other systems. And for the performance part, the SQL engine, the planner, will do the auto optimization to derive a best execution plan based on the cost-based style and for the most efficient string and batch processing. Yeah, now let's look into the two important concepts in Flink SQL. The first one is string table duality. This is the basis to unify string and batch word. Yeah, maybe the abstraction of the string table duality itself may be too abstract. But if we imagine and take the relational database as an example, it can be simply understandable. Yeah, take a table in relational database as an example. If the application continuously do some insertions to a table, let's say the click table has no primary keys, and all the operations are just insertion. Backed by the database, it will record the change logs to record all these changes. And for the availability, where the DB maybe due to some reason, it crashed, it can be restored without any data loss. So take this example, we can understand what change logs is. Change log is another presentation of a table in DB, because every change in the table will be recorded as a change log. Yeah, in the picture, this is append-only logs related to the table, because as just mentioned, all the operations are insert-only operations. So we can see there are just insertion operations in the logs. Yeah, of course, there are other operations like updating or deleting in the database. So when a table has let's say, has a primary key and the application maybe do some upsert or delete for the table on the table, then the change log will contain some related update. For the picture, we can see some deletion for the previous lines, and the latest records was appended to the log. So this is the basic example of how table and string looks like. These two can be conversion, and it's interchangeable. So a table can have a presentation as a string, and a string also can be, let's say, when we insert a changelog to another new table, we will have finally we will have a same version table as the original ones. So this is the conversion of the two. Yeah, string table duality and the conversion not only happens in the table itself. In streaming computing, it also affects the operations or the calculations. So let's see the example. The logs, the append-only change logs in the click table as the input of a group aggregate calculation. Then this aggregation will take this input to evaluate the new result and generate a new updating table. This will also generate a new changelog string. Yeah, this is the first concept of circuit word. Then I will show you the notions of time. As just mentioned, this is very important in application, event-driven computation. And in circuit word, it's also very important. Yeah, what's event time and processing time? Yeah, as Xintong mentioned, processing time is the machine time that when the operators see the actually records come in. And for the event time, it's the moment when the event just occurs. It's exactly the time attribute of the event itself. It will not change by other systems. So in the picture, we can see event 1, 2, 3 has its own timestamp to illustrate its event time. And at the right side, this is sequential processing by an operator, let's say just a filtering or calculation. It will be a sequential timestamp different from the event time itself. Yeah, in streaming world, we can see two facts. The first is we cannot avoid auto-order events. Yeah, in the picture, we can see the red event is strictly ordered, and the two green events is something late. Let's say they are late event. So we can't avoid auto-order event. Then how can we deal with such things? But fortunately, we can observe a fact, though we cannot avoid out of order event, but they are roughly in order. So we can have a mechanism, let's say the watermark, to divide these events into pieces or into buckets. Yeah, watermark is from some perspective from the operator to watch all the input records to see various kind of event, in time ones or later arrival ones. Watermarks most important it's most used as the condition to judge if time range data is complete or not. Yeah, let's see the example of a watermark definition. The watermark for TS as TS minus 3 seconds. It means it will calculate watermark based on the event time and minus 3 seconds. This also means it will tolerate 3 second late arrival data. So those events which can come in less than 3 seconds late, it will be accepted as useful data. And if it beyond the gap, it will be judged as late event, and the Flink SQL will choose to drop it. Yeah, this is the second concept of the Flink SQL, event time and watermark. Now let's see some concrete Flink SQL use cases. Yeah, this is 3 classic scenario listed on Flink website. For the first one, event-driven applications, users usually use data streams, APIs, as the most commonly used case. And also, Flink SQL can do that as well. For example, use the pattern match CEP syntax, let's say. And for the second one, for the data engineering, it's very common use case, stream batch analytics. And we can build, let's say, either offline or real-time data processing. And the last one is maybe we can see it as the infras, yeah, to build data pipelines and ETL for data warehouses and lakehouse. Yeah, this is a concrete example for how Flink to build batch and real-time ETL. Yeah, for the batch world, let's take the iceberg as an example. Flink can do various ETL operations based on the batching style data. And together with the scheduling system, for example, Airflow, it can be scheduled, for example, daily run or hourly run to do the pipelines. For the real-time ETL, Kafka is popular, so cope with Flink, it can provide real-time ETL. This is useful to build a further solution for the data warehouse or lakehouse. Yeah, this is a classic layered warehouse architecture. We have three layers of data. And for each layer, we can have Flink engine and cooperate with Kafka to do all these transformations. And then lastly, we can update the final result into the relational database or the KV systems to serving the BI visualizations. Yeah, after these use cases, let's go over some concrete Flink SQL functionalities. Yeah, Data enrichment is very useful in data engineering. Many data or typically in relational database, we should follow the design patterns, do not have too many data redundancies. So we should join this data back as enriched, detailed info for our users. So this picture shows the commonly used four type of joins. They are supported by Flink SQL. Yeah, I will give you some simple introduction. Yeah, for the inner join, yeah, it represents some intersection for the data sets, let's say. And for the left join, except the intersect part, and the left side will be all reserved if it cannot join a right record, but will pad null columns as the left ones. And full outer join can reserve all the data on both sides. And the right out join is vice versa against the left ones. Yeah, besides the join type itself, we have another dimension of joins. We have lookup joins, regular joins, interval joins, or temporal table joins in Flink SQL. For the first one, lookup join, it is useful when you have some dimension, let's say dimension table in remote storage system, which can provide some files in index-based scan or point lookup. Then if you have a main string from Kafka, the lookup join can handle the Kafka input and do the real-time lookup from the remote storage. And finally, after the join operation, it will output the enrichment records. Yeah, compared to the lookup join, the regular join is something like, let's say, the advanced lookup join. It can process two inputs compared to just the one input of the lookup join. Regular join will be triggered by each input. Every record come in, it will do a local lookup to finish the join operation. The local lookup is based on the local stored state. Yeah, this is the stateful keyword in Flink. The regular join uses the local state to store both sides of input records to build the fast lookup, and also keep them as the high available storage. So with this infras, the regular join can do a more advanced enrichment than lookup join. Yeah, besides enrichment, the aggregation is also very important in data processing. Yeah, before we look into the aggregation, let's see some window functions. It's in streaming word, the time window. Yeah, we just mentioned the event time and the watermarks. And maybe some of you already seen a tumble window example in that picture. Yeah, we have four kind of time window in Flink SQL. They are tumble window, session window, hop window, and accumulate window. Yeah, they are very useful in data processing. It's, one of the key problem some users told me it's hard to understand unlimited or infinite data streams calculation. The window is very useful to take it down. window can split the infinite data strings into several dedicated buckets. And when we have these data buckets, the calculation will turn back to the batch style. All data will be static in this situation. So let's see how tumble window looks like. Tumble window is useful when we need to calculate, for example, every minutes, every hours, unique visitors, or pay orders. So in this situation, we can use a simple tumble window. And we just need to define a window size based on the event time column. Yeah, in the example, the interval is 10 minutes. So every 10 minutes, the Flink SQL will calculate a window result for the downstream. And for the session window, it is a slight different from the tumble window. It has a more, another additional definition by the partition key. Yeah, for example, the item. This example shows 5 minutes session window based on the item, every item. Yeah, we can imagine, the session gap means there will be no more event after this gap come. Then the previous records comes into a finished window. Then we can have a deterministic result for the previous window. And if the previous window close, a new window will come. This is the basic mechanism of the session window. And hop window, another say is we can say it sliding window. Yeah, it has a total size for the window and also a step size. In the example, the total size is 10 minutes and the step is 5 minutes. So every 5 minutes, the window will move. So this is useful when we need to calculate, let's say, the statistics of last 5 minutes or last 10 minutes. This can be done by the hop window. And the last is the cumulative window. It can be, it is interesting in window world. The cumulative window is different from the previous three ones. It has a total window size, the max window size, let's say 1 hour. And it has a 1 minute window step, also has a window step, but different from the hop window. It does not slide before the window end. So for the 1 hour cumulative window, it can emit every 1 minute and accumulate all the result from then to now. Yeah, here is a detailed window operation, a window aggregation example. We calculate counter records, counter result based on the click log, and we will have the window, the result. Yeah, on the right side, there are 2 batches of window result. Yeah, window aggregation or window calculation makes the string computing more simple to users, but it has its own limitation. Because we need to wait some late event, so the window aggregation can't be that freshness. Yeah, let's assume we have a 5-second size tumble window, and we have a 3-second offset to wait the late event. Then we have at least 8-second latency. But sometimes we need to provide the fresh data as much as possible. So another choice is group aggregation. Yeah, we use the same input table and do the similar calculation. And without the window, we use a normal unbounded group aggregation. In this style, we can imagine this calculation will be triggered for every input record. So it can provide the second level real-time results. This is very useful in something like the real-time analytics or the detect result. Yeah, after these examples, besides that, Flink SQL has more building operators, except the basic select, filtering, order by, limit, and we have the window aggregate, support the distinct calculation, the group aggregate, and also over aggregate. Yeah, for the join operators, we support those 4 joins and also something like user-defined table functions. Other operators like top n, the ranking operators, and the duplicate, and also window deduplicate and window top n. And besides that, you can explore more on Flink website. Besides the building operators, we have various building functions. We can divide them into 3 categories: the Scala functions, the table functions, and the aggregate functions. They are commonly in Flink SQL. The most used is the Scala functions, both the string functions, JSON functions, temper functions, arithmetical ones, and for comparison, for logical judgment, and others. Yeah. Besides the building system functions, users can also extend his own functions by the interfaces. So besides the 3, as just mentioned, we have 2 more ones. One is the async Scala function. It is newly introduced. Compared to the normal Scala functions, it can do something, let's say, interact with external storage, just like a while HTTP request or some RPCs. And because it uses asynchronous style, it can tremendously improve the import throughput. And for the table aggregate function, we can see it as a combination of the table function and the aggregate function. Yeah, let's do a recap for this topic. Firstly, we introduced the Flink SQL, what it can do, and then the 2 important concepts in Flink SQL: string table duality and event time and watermarks. Lastly, the Flink use cases go over some concrete functionalities in Flink SQL. Yeah, this concludes the content for today's topic. Thank you.
Thank you so much, Mr. Lincoln Lee, for the Flink SQL. Ladies